Thank you all very much for joining us. And we're going to be talking about Bitcoin, blockchain, and how it would look in Neo4j. And I have with me here Greg Walker, who is the creator of the website Learn Me a Bitcoin, where you can learn all about cryptocurrencies and Bitcoin. So I will be recording this session, especially for those who may not have been able to make the switch. And we'll be emailing that out to you, as well as a copy of the slides later today. So just keep an eye out on the email address that you use to register. And with that, I'll hand it over to Greg.
Okay, thank you very much. Just double check, can you hear me okay?
Yes.
Okay, brilliant. Right, okay, so I'm gonna do a quick presentation on how I've been using Neo4j to store the Bitcoin blockchain. So I split this presentation up into 4 main parts. I'm going to start out with the Bitcoin basics. So basically going to describe the basics of how Bitcoin works. Basically, it's just a computer program that runs on a computer, and it connects to other computers running the same program to create this Bitcoin network here. And all they basically do is they share this single file called the blockchain. And that's basically what I've put into Neo4j, this blockchain file. So after I've covered the basics of how Bitcoin works, I'll look at then this blockchain file and see what the data looks like. So when we know what the data looks like, then we can understand how we can import it into Neo4j, and you can understand why I've used Neo4j for storing this database. After that, then I'll move on to the import process, and I'll show you how I've actually decoded that data and inserted it into Neo4j. And then finally, at the end of the presentation, I'll go into the browser and I'll show some examples of what the data looks like when it's inside Neo4j. So that's the intro. So I'll just carry on then and get started with the presentation. Basics of Bitcoin. Bitcoin, like I said, it's just a computer program. And when you run it, it connects to other computers on the network running the same program. And they all share this same file called the blockchain. So these 3 blocks here represent the blockchain, which again is just a shared file. So when you use Bitcoin, so you want to make a transaction and send someone some Bitcoins, what you do is you create a small line of data. So this little green line here represents the data, and that represents the transaction of moving the Bitcoins from one person to another. So what you'll do then, you'll insert this transaction, this line of data, into one of the nodes or one of the computers on the network, and they will store it in some of their temporary memory called the memory pool. And what that node will do then, they'll pass their data on to the nodes they're connected to, and so on, until every node on the network has got a copy of this data that you've inserted into the network. As you can see, it hasn't actually been written to this blockchain yet. It's still being stored in temporary memory. This is called the memory pool. So what happens then, you have the process of mining, where one of these nodes then will try and add the transactions from their memory pool onto this blockchain. So let's say this one does it. It's managed to add its transactions from the memory pool onto the blockchain for the process of mining. I'm not going to cover how that works, but it's basically one big competition between all the nodes on the network to try and get their transactions onto the blockchain. But this one here, this particular node was the first one to do it. So there it is. It's been added onto their file. What they'll do then, they'll pass on that block of transactions that they've mined onto the file onto the nodes they're connected to, and they will validate it, and then add it onto their file also, and so on, until eventually everyone gets an updated copy of the file. And that's basically how Bitcoin works. It's just a file sharing program, a lot like torrent, but the cool thing is that anyone can add data to it. And the way the data that Bitcoin uses is transactions. So this is one big file of transactions, and that's how Bitcoin allows you to use or create a decentralized currency. So there we are. This Bitcoin now belongs to this person because the transaction is now in the blockchain. I'll stop there for a second. Does that make sense so far?
Yeah, everything's great.
Okay, yeah, sorry. Okay, brilliant. Right, that's fine. So that's the basics of Bitcoin. Again, just a shared file. So what I'm going to look at now is what this blockchain looks like. Let's look at the data so we can understand how it works and what it's doing. And then we'll understand why I've put it into Neo4j. So let's say this is a blockchain. the blockchain is just one big file, but it's called the blockchain because there are blocks of transactions. So after every 10 minutes, a new block of transactions will get added onto the file, and that's why it's called the blockchain. But if you wanted to visualize what the data inside the blockchain is actually representing, the best way to think about it is that inside each block, there are lots of batches of individual bitcoins, and they each have their own individual value. So it's a bit like thinking of going into a bank and a bank having lots of lock boxes. It's very similar to that. And the way people own these bitcoins is each of these individual batches of bitcoins has a lock on them. And these are unique locks so that the batches have been locked to a specific person, so that only specific people can spend them or move them. So that's probably the simplest way to visualize what the blockchain is, just batches of bitcoins with locks on them. So if I were to move this blockchain to the side here, again, we have this person and they want to send bitcoin to someone, so they create a transaction. So this green line here represents a piece of data, which is just a transaction. I'm not showing you the actual data. I'm just trying to keep it simple with this little visualization here. So what happens is if you were to make a Bitcoin transaction, what the actual data is doing is, in the first part, it just selects a batch of bitcoins from the blockchain. Each of these batches of bitcoins have their own unique identifier, so you can select anyone you want. What you'll do then, so imagine this is the batch of bitcoins. It's obviously got a lock on it. So in the second half of this first piece of code, you have what's called unlocking code. And all that does is it allows you to unlock this batch of bitcoins so that you can send it to someone else. So again, the first part of a transaction data or any transaction just selects some bitcoins and unlocks them. Then in the second part, what you'll do, you'll create a new batch of bitcoins from the one you've just unlocked, and you'll put a new lock on it. So before, this batch was locked to us, we've unlocked it, and we've created a new batch with a new lock on it, and this lock can only be unlocked by this person. So when you think of a Bitcoin transaction, instead of thinking of it of sending bitcoins from one computer to another, that's not quite how it works. What really happens is you have your own private key, your own set of keys, and someone else has their own set of keys on the computer. And what you do when you want to send them some bitcoins, you just use your key to unlock a batch of bitcoins that you own. You create a new batch and you put a lock on it, so that the person you want to send it to, the only person who can spend them is the person you're sending them to. Or so basically the only person who can send them is the person who can lock this particular lock you've created for them. So then going on from there, if this person wants to send their bitcoins onto someone else, they'll do the same thing. They'll use their key to unlock this special lock that we put on this batch of bitcoins for them, and they'll move it on to someone else. So as you can see, bitcoins are connected together in this sort of series, like so. I've been calling these batches of bitcoins up until now, but the technical term is outputs. So this is an output, this is an output. All of these batches of bitcoins in the blockchain, they are also called outputs. But just to be technically correct, when we're using an output or spending an output in a transaction, we refer to it as an input. So every transaction takes an output, spends it, and creates a new output, but we call that spending output the input. So inputs and outputs. That's how a transaction works. To build on that, obviously I've sent 10 bitcoins from one person to another person. You don't have to, because they're in batches, you have to use up the entire batch. So say you wanted to only send 8 bitcoins to this person instead of the whole 10. What you'll do, you'll create this output of 8 bitcoins and lock it to this person's address. But then that remaining 2 bitcoins, our change, we actually create a output for ourselves and we lock it back to an address or back to a key that we own. So when you create a transaction, you open up an output, spend it, create an output for the person you want to send it to, and also create your own change output. But within a transaction, you can actually create as many outputs as you like, but this is a typical transaction, just taking some existing Bitcoins and creating some change for yourself. Similarly, say you want to send a greater amount than one particular batch, what you can do, you can select multiple batches or outputs from the blockchain, and you can collect them together to create one bigger batch. So as long as you can unlock them, you can combine these two inputs together to create this bigger batch that you want to send to someone. And same as before, what you'll do then, you'll also send your change to yourself. So again, this is a very typical kind of transaction, just taking out batches of Bitcoins outputs and creating new batches from them. And they're all sort of connected together like this. So because the blockchain is full of thousands of transactions, if you just slowly build up transaction upon transaction, they obviously take outputs as inputs and then create new outputs from them. So with every new transaction that gets added onto the blockchain, you get a transaction system that looks similar, something like this. So as you can see, it's starting to represent a graph. So with every new transaction, it sort of extends this graph, like so. So when we created this transaction here, or when you create any transaction, all you're doing is you're selecting spendable outputs from this graph and creating new outputs from them. So basically every transaction extends this graph here. So this transaction here made this adjustment to the entire Bitcoin transaction graph. These are called unspent transaction outputs. These are like the sort of the live spendable Bitcoins, and these grayed out ones, they've already been spent, so they can't be used again. So they're kind of like dead Bitcoins or used up Bitcoins. These are also called UTXOs for short. So if you ever see that term, that's what it's referring to. Lastly, where do these original Bitcoins come from? These ones here. Well, with every block that gets created or mined, it has something called a block reward, which is basically a new batch of Bitcoins that did not exist before. And the miners, they can collect these block rewards like so. So when a miner mines a block, they will just collect this fresh batch of Bitcoins that did not exist before. So all these orange, dark orange outputs here, they were created from transactions. So when you create a transaction, you can only spend, well, that's wrong. Basically, the block reward can only be collected by the miner. And so this is where new Bitcoins come from. So as you can see, all the transactions are connected together and all the blocks are connected to the transactions. The way a miner will collect this block reward, at the very top of a block is space reserved for a miner to put their own special transaction there. This is called a Coinbase Transaction. So that just allows them to send themselves a batch of Bitcoins that did not exist before. They're only allowed to do it because they created this block. So there we are. So that's basically what the blockchain looks like if you had to visualize it. Most importantly, it's just this sort of transaction system of moving Bitcoins from one place to another, being able to split them up and collect them back together again, split them up like so, but they're all connected together to create this sort of graph structure. And that's basically why I chose to use Neo4j. It's why I decided to import the Bitcoin blockchain into Neo4j, because I thought the data represented a graph. Neo4j is a graph database. I thought I'd do that. I didn't do any testing. It just seemed like a natural fit, so I just went for it, and it seemed to have worked quite nicely. So that's what the data looks like. What I'll move on to now is the import process. So this blockchain here, it sits on your computer. If you run the Bitcoin program, you can find all this data on your computer, because again, it's just like a shared file. So on Linux, it's in your home directory, in your .bitcoin directory, / blocks. I don't know what it is on Mac or Windows, but it should be easy to find. And then if you look inside there, the blockchain is just split up into multiple different files, each beginning with BLK and then a number. So this is the first one, second one, so on. So basically, instead of it being one massive 150 gigabyte file, it's split up into much smaller, about 132 megabyte files. So if you want to import blockchain data into Neo4j, these are the files that you need to read. And so these files, they all follow the same sort of structure. It's basically just loads of transactions, one after the other, but they're all contained inside these little blocks. So again, the blockchain, just lots of blocks of transactions, but it's mostly transactions. Each of these blocks, they follow the, well, yes, each of these blocks, they follow the same structure. So when you come to parsing the data, you have a block header at the top, and this has like the time and like a version number, just some metadata that describes the block. After that, you have some extra data to tell you the transaction count, which helps with passing through each individual transaction. And before the block, you have magic bytes, which is like a marker to allow you to spot the start of a block and the block size. So again, that helps with passing through the block. So it's quite a simple structure. You have a block header and transactions and some extra metadata to help you with passing through the file. And if you understand how this works, then you can easily read through the entire file or all the files because they all follow the same pattern all the way throughout. So when I imported the blockchain data into Neo4j, I just used to run through these files and import the data for each block and transaction as I run into it. So let's say I'm reading through this file here. Let's say this represents my Neo4j browser. I'm just going to show you how I read through the data and import it as I go along. So again, I'll just start reading through a file. I run into a block header. So what I'll do then, I'll create a block node. And because each block creates new Bitcoins, I'll create a special node coming off it called a Coinbase node. And each of those nodes has a value. Each Coinbase node has a value, like a set number of Bitcoins. So I'll put that as a property on the node. So that's the block done. I'll move on now to the transactions. And with each transaction, I first create a transaction node, and then I'll connect it to the block, or because each transaction is included inside a block. And then after that, then each transaction takes Bitcoins as an input. This is the Coinbase transaction, so it spends the new Bitcoins. And then in the second part of the transaction, it creates an output. It moves the Bitcoins from one place to another. And so I give that, each of these nodes, the name output and the relationship out. And inside each of these output nodes, I give them a value, a number of Bitcoins, and also I put the locking code as a property on the output as well. So if I just move that to the side, that's the Coinbase transaction done. Move on to the second transaction. Same thing again, just create a transaction node, connect it to the block, and then take some Bitcoins in. But if you remember, each of these outputs has a lock on them. So inside this transaction data, there's some code that allows you to unlock this output so they can be spent or moved into a different output. So I'll put that unlocking data as a property on the relationship, like so. Then same again, just create some outputs. This particular transaction, let's say, created two outputs. So it's taken one input into the transaction and it's spat out two new outputs with their own unique locks on them. So this is basically a typical transaction, what it looks like in the Neo4j database. Finally, nearly there with the basic structure. Each of these locks, they basically lock an output to a specific address, which is a lot like an account number for Bitcoin. So if this output is locked to someone's address, I will create an address node for that particular address, and I'll put the address as a property on that node, and I'll give it the relationship of locked, like so. So imagine this output here was locked to a different address, it got unlocked, create a new output, and that output is locked to this address. If two outputs are locked to the same address, I'll just lock them to the same node. So if this is like a typical transaction, let's say I had 50 Bitcoins, I sent 40 to someone else to their new address, and I basically sent the change back to my address. And that's the basic structure for how transactions look inside Neo4j. Third one, just for good measure, same again, just create a transaction node. I'll connect it to the block. I'll take some Bitcoins in. But just to be clear, when you make a Bitcoin transaction, you're not restricted to only being able to spend the outputs that have been created inside this block. You can spend any outputs that exist in the blockchain. So imagine that I've already inserted a block full of transactions. So similar to before, this is two transactions from an earlier block. I can just select those existing outputs as an input into this transaction node, and then I'll create two more nodes off it, like so. And this is, if you understand how this worked, then you can understand how the entire Neo4j database is built using blockchain data. Again, so imagine I've inserted another block. Here's another load of transactions with outputs. They're all, this block here has extended the graph this way. And obviously, each transaction belongs inside a block, and also each of these blocks are connected together or chained together. So with every new block that gets added onto the blockchain, it builds on top of an existing block, and that's why it's called the blockchain. So there we are. So that's how it looks. So over time, as you read through all the files and insert them into Neo4j, the blocks you get a longer chain of blocks, and the graph gets wider. I haven't filled in the visualization here out of laziness, basically, but imagine that this graph is getting taller and wider with every new load of data that gets added from the blockchain inserted into Neo4j, like so. So if you read through every single file, there are currently roughly 1,100 of these individual blockchain files, which is about roughly 140, 150 gigabytes, I think, at the moment. And that's a total of basically 500,000 blocks. And even though this data here is roughly 150 gigabytes, once you've inserted it into Neo4j, it's about 6 times the size. So it's a very large database, really, and it's currently about 800 gigabytes. It probably could be smaller, but I haven't really worked to make it smaller. But that's just basically from my basic experience of importing the data into Neo4j. It's about 6 times the size, so it's a very large database. But even though it's very large, it does seem to run very well, nonetheless. Right, so that's the whole import process. It was a bit of a long haul, but thank you for bearing with me as I went through that. But now we know what the data looks like, it should be quite easy to explore it now and understand what's going on. So this is the database. I've got this ready to show you. These are all the blocks, like I tried to describe. They each create a Coinbase. These are all the transactions connected to each block. And if we were to sort of follow each transaction, they take inputs in, batches of Bitcoins in, and they spit Bitcoins out, like so. And again, they'll go into another transaction and come out again. And each of these outputs are connected to different addresses, like so. So if you double clicked on an address, there we are. You can get all the Bitcoins that are connected to this particular address. Click on this one. See, that's only one there. There you are. This shows all the Bitcoins connected to this address. So there we are. Similarly, if you wanted to follow the path of a transaction, so this output here got used up into this into this transaction. It took a load of inputs in, and it spat out, oh no, lots of in there, right there. Okay, well, it spat out quite a few outputs. So this is more of a complex transaction. But it just goes to show that you can follow basically the movement of all Bitcoins throughout the entire blockchain, and nothing is hidden. What you can do then is, because it's in a graph database, you can do some cool stuff. Like, for example, if you wanted to see if two addresses are connected together, you can just insert a simple query and then run it. And then if it comes out in time, there we are. You can see that this address here is connected to this address through these transactions. So trying to do that in a non-graph database, I think, would be very difficult. But with a Neo4j, it allows you to see any connections between any two addresses. Similarly, here's another example. There we are. So there's one address here, and wanted to see if it's connected to this address. I can see that it's being connected through this transaction into this address, out into this transaction, and then over to this address here. So if you want to do some sort of analysis for like fraud detection or something like that, Neo4j would work very well with the Bitcoin blockchain because they're all connected together. I think that covers basically what I wanted to show you in the browser. Again, it's quite nice for exploring. This is like a live database here, and this is the actual blockchain. And you can just, expand every block, expand the transactions, and follow the path of transactions any way you like. This database here, I'm actually using it to power my website called Learn Near Bitcoin. It's just meant to be an educational website to try and explain how Bitcoin works. Like, again, the only reason I use Neo4j because I felt it was a natural fit for Bitcoin data. So I use that to power this very simple blockchain explorer. So you can browse all the blocks. So this is like the latest block. These are the latest blocks. This is a block for all of the transactions. And this is a typical transaction. So this is sort of my very basic attempt to try and outline the structure of Bitcoin data. You probably find this graph more interesting if you're used to using graphs, because this is just a sort of basic representation of the data. And you can, browse addresses, transactions, the blockchain, and this is all live now. So this entire website is running off this 800 gigabyte Neo4j database, and it seems to be pretty fast. Like, I've never had too many problems with speed. So yeah, I think that's the end of the presentation. I think I've covered everything I wanted to cover. Is there any questions before? Any questions at all?
Yeah, no, thank you so much, Greg. That's really cool. So I have a few questions that people have been posting in the live chat, and just for anybody who wasn't aware, please feel free to post questions there. I will try and take some right now. And again, a reminder, I'll send out a recording of this session for anybody who may have joined late because of our technical difficulty. But so let's see, some questions to start off. So it's clear to see how Neo4j is being used to represent the blockchain locally, but what are some of the advantages for doing this?
So why would I use Neo4j for? Oh, okay. Yeah. The reason I use Neo4j is because I wanted to build my own blockchain explorer, and when you look at a transaction, I thought it'd be cool to be able to follow the path of Bitcoins. So going from this output to that output, and going back through the whole connections. You can't do this with the native Bitcoin database, or you can, but it'd be very slow. It would take a long time to find each of these individual outputs. And so the reason I use Neo4j is because it allowed me to create this structure where you can click on any output and follow the path of them. So I think you could do this with the blockchain data. It's all just binary, but putting it into a database allows me to do more cool stuff with what data I can show to people on this browser. Also, I think when you put it into Neo4j, you could do a lot more analysis on it, like fraud analysis and things like that. I've not done that. All I've wanted to do is just create a fast, easy to use browser. So that's the reason I use Neo4j.
Okay, great. And can you talk about what you use to parse the block files?
Yeah, I wrote my own decoder. A block. So look. So let's say basically a transaction. It basically looks like this, and they all follow a similar structure. Again, it just follows the structure of taking inputs, selecting them, unlocking them, and creating outputs. So I just wrote my own decoder because I was learning how Bitcoin worked. So I wrote it in PHP. But I think if you really wanted to decode these transactions, you could find like a library for whatever language you're using. There are a lot of libraries out there now for decoding blocks and transactions. I wrote my own just for the sake, because I wanted to learn how it worked, but you could probably use a good library instead.
Okay. And you had mentioned that it might make sense to use Neo4j if you wanted to detect fraud within the blockchain.
Yep.
Can you elaborate on that a little bit? Like, how would you detect fraud by just visualizing the graph? And do you have any ideas on how fraud would even happen within a blockchain?
Probably just following, if you wanted to see if addresses are connected together, like if someone's trying to hide the flow of money. I have not really done a lot on this, so I can't really expand on this too much. But I know there are some websites where people try and, when Bitcoins get stolen, they want to see if they end up at an address that people can identify. So you can sort of, if your Bitcoins get stolen, you could use this database to maybe see where they've gone and see if there are any patterns of where they're being moved to.
Okay.
I've not done anything serious with this. It seems like it's possible, but I've not done anything with it. So
yeah,
I
definitely.
can't really answer that question terribly well for you, sorry.
Yeah, I know on our website we do have a lot of resources around fraud detection, not necessarily to do with blockchain, but with more so banking data or financial services. So I assume it would be something similar if anybody wanted to go check that out on our website. And then I guess, I know we're a bit over time, but we could take one more question. So is there available data for analysis, or is this all public?
Yeah, I've got this basic browser ready. I've got this browser available. So if you wanted to use it, you could just send me an email and I'll give you the password to log in if you wanted to. But because it's such a large database, it's about 800 gigabytes. I don't know how to sort of share it and make it terribly publicly available. I mean, the most public thing I've done with it is just making this sort of web interface. But there's also this sort of Neo4j browser interface. And if you want to access that, I can give you the login details. My email is on my website. Go on Limia Bitcoin. Go on to About Me. And my email is here somewhere. There. Lastly, while I'm on the website, if you wanted to see how I've done this in a bit more detail, how I imported it, I've written an article that shows it's basically like an article version of what I've just tried to describe in this presentation. But it might go into a bit more detail with help with reading the blockchain and stuff. So just go on the website. If you want to use this database and explore it for yourself, just send me an email and I'll give you the password.
Okay, great. So I think that's all the time that we have, but thank you so much for joining us today, Greg. I think that was a fantastic presentation and definitely very timely given all the craziness happening with Bitcoin this week.
Yeah, it's a bit frenzy.
Yeah. But for everybody else, I will send out a recording of this. I'm sure some of you had to join a bit late. And yeah, definitely go check out Learn Me Bitcoin's website, and as well Neo4j's website, especially if you're interested in fraud detection. So thank you so much for joining us, and enjoy the rest of your day. Thank you.
Thank you.